Okay. For this example, it had the absolute value right here. Okay. So same question, different function. Given f of x, 4 divided by absolute value of 2x minus 3. Find the domain of f of x. Write the answer in set notation. Find the domain of f of x and write the answer in interval notation. So remember, when you are asked to find a domain, always look at the function. What is its domain? What x? Find the x that when you substitute in the function that would make the function undefined. If that happens, if such x can exist, that means you should not include that x in the domain. Okay? That means you would exclude it. So this is a fraction. So what is the domain of this fraction? Let me rewrite this fraction. 4, 2x minus 3, right? So for a fraction, we don't want any fraction or any number on top divided by 0, right? Because it would be undefined. So that means we want to find out what x is that in the denominator that when we plug it in would make the denominator equal to 0. And we'll try to avoid that x. So we'll set 2x minus 3. So we set denominator equal to 0 and try to find what x is that would make this equation true. So recall, for absolute value of 0 is 0, okay? So that means this equation would be true if the thing inside the absolute value is 0. So that means 2x minus 3 equals to 0, okay? Solve for x, we use the addition principle, add 3 both sides. 2x plus 0 equals 0 plus 3 is 3. 2x plus 0 simplified to 2x, divide by 3. Using the addition principle, divide both sides by 2. 2 divided by 2 is 1. 1 times x is x, equal to 3/2. Okay? So that means if you substitute this x, 3/2, in here, the function, this domain would turn out to be 0. So 4 divided by 0 is undefined. That means we try to avoid this x, 3/2. So if you write down the answer in set notation, domain, okay? You would write this case x of x such that x is a real number and x not. We don't want it. Okay? So the domain is x. X can be any number, but except 3/2. Because you plug 3/2 here, denominator turns out to be 0. And any number divided by 0 is undefined. We don't want that to happen, so we say avoid it. X cannot equal to 3/2. So that's part A. For part B, we write this in interval notation. So again, if you have hard time, draw a number line, 3/2, anywhere on the number line. We don't want it, right? So we use parentheses. Because for this case, is x is any number. So any number here is fine. On the left of 3/2 is fine. Any number on the right of 3/2 is fine. So we'll say, we use parentheses here, represent from this 3/2 to the left. We use this parenthesis here, from this 3/2 to the right. And to the left of 3/2 can be any number, right? And smaller, that means to negative infinity. To this right means any number bigger than 3/2, right? And increasing to infinity. Do you see that? We're almost done. So the answer in interval notation, using this number line to help you visualize, you can come up with negative infinity to 3/2. We don't include it. Make sure you union. For negative infinity, we use left parenthesis, union with 3/2. We're not including it. We use parenthesis to infinity. And for infinity, we write parentheses. So this is the answer for this example. And up to this point, we're done with section 2.3. And let me give you the homework list. For section 2.3, 1 to 9 ought, 21, 23, 29, 35 ought. Okay? Make sure you practice, understand my lecture note and the homework, because it will be very helpful for you when you do the quiz and the test. And make sure you keep track of the class. I know this is a hybrid class, so it's very quick, but you'll be done with it by October 17. So I'll see you next time. Thank you.